What's up, guys? This is Mason Williams, and this is our Chapter 1 challenge featuring me, Sid Lawani, and Jack Majeski.
What's up, guys? Sid here. Today we're going to be talking about reaction time, measurement, average speed, graphing motion, negative acceleration, and using models.
Reaction time is the time it takes a person to respond to something that just happened. It is especially important when driving a car because it means the difference between life and death. Avoiding accidents, stopping at stop signs, and stopping when you see a red light are all examples of drivers using their reaction time. It is commonly known that a person's reaction time is greatly increased when a person is distracted, usually by cell phones. This is a video showing a person using their reaction time. He must use his reaction time to catch the ball before it falls on the ground.
When measuring, there are two different errors that can happen: systematic errors and random errors. A systematic error is an error that occurs when the experimenter uses the wrong tool or uses the tool incorrectly. A random error is an error that cannot be calculated and cannot be avoided during the experiment. However, scientists try to fix random errors by finding patterns in the data and adjusting it slightly. The best and easiest way to show precision and accuracy is by using a target. Precision is how close together the data is. Accuracy is how close the data is to what the data should be. There are three pictures below which represent precision and accuracy. The left picture shows precision but not accuracy because the points are close together but not close to the middle. The middle picture shows precision and accuracy because all the three arrows are both close together and in the middle of the target. The picture on the left shows accuracy but not precision because the points are all close to the middle of the target, but they are not close together.
Speed is the distance traveled for a unit of time. Unlike velocity, speed has no direction. There are different types of speed. One is constant speed, which is speed that does not change over a period of time. It can be seen through a series of strobe lights. Another is instantaneous speed, which is how fast a car is going at a specific time. Average speed is the total distance traveled divided by the time it took to travel that distance. Two examples of average speed are miles per hour and meters per second.
Correct.
Velocity is speed, but only in one given direction. The formula shows how to find average velocity, the change of distance, and the change of time. To find the variable that you need, you can use the picture on the bottom of the slide. If you want to find distance, then multiply average velocity by time. If you want to find average velocity, then you do distance over time. If you want to find time, then you do distance over average velocity.
Acceleration is a change in velocity with respect to a change of time. It is essentially speed with respect to time in a given direction. Velocity is a vector quantity because it has both size and direction, and a vector is a quantity that has both magnitude and direction. Positive acceleration is an increase with velocity in respect to time. However, negative acceleration is also an increase with velocity in respect to time. The difference is that positive acceleration is going in the forward direction, but negative acceleration is going in the backwards direction.
Negative acceleration is a change in velocity with respect to time of an object by decreasing speed in the positive direction or increasing speed in the negative direction. This usually occurs when a driver is approaching a red light. The acceleration of an object is determined by how fast the velocity of an object changes with respect to time. The braking distance is how far the car travels after the brakes have been applied.
Braking distance has many factors. These are the environment, the tires, the weight of the car, and most importantly, the speed at which the car is going. The total stopping distance is the time it takes for a driver of a car to move their foot to the brake pedal and start pressing down on it to the time it takes the car to completely stop. Specifically, it includes reaction time and braking distance.
This is a graph that shows the parts of total stopping time, which is in yellow. The light blue is the reaction time, and the dark blue is how long it takes for the car to stop.
When seeing a yellow light, a driver's first instinct is to speed through. This has proven to be dangerous on several occasions. An intersection consists of two spaces, the go zone and stop zone. The go zone is the distance that an automobile travels while the light is yellow, minus the width of the intersection. This tells the driver that if it is safe to pass through the yellow light. The go zone increases when the yellow light time is increased. This gives the automobile more time to make it through the intersection safely. It is also increased when there is an increase in speed. This means that the vehicle can travel a greater distance during the time that the light is yellow. The go zone decreases when the width of an intersection increases. This is because it forces the vehicle to travel a greater distance to make it through the intersection. There are two dangers of stopping in the go zone. First, you will end up in the middle of the street. Second, if you try and go through the intersection from the stop zone, you run the risk of getting a ticket for running a red light. Thanks for watching.